Okay, so Unit 3 test review. I've highlighted a few things. It says graph the polynomial function, this big old beast, and estimate. Now that's the trigger word because it kind of tells you to relax, use your graphing calculator, do the best job you can, estimate the zeros and the turning points. We'll talk about that in a minute. I've got it typed in my calculator. Now I'm going to show you something. I'm going to go to my Windows, and it's kind of wacky. So I would recommend checking your windows. Generally speaking, you want to go from -10 to 10 just to get started, and then the rest is pretty good. So now I'm going to go back to my graph and now graph it, and there should be some really good stuff here. Come on, graph. There it goes. All right, so as you can see, it's saying estimate. In other words, don't get too persnickety about it. I can see, you know, basically it's like copy the graph, and you can see it goes way down low, 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 and it goes up quite high. I could change my window, but generally speaking, they're just saying go ahead and try your best to estimate it, copy it. I'm going to pause this. So I've got to here, just trying to copy it a bit, trying to nail those estimates of our zeros, which are just x-intercepts. And that low point, again, an estimation, where does it cross the y-axis? If you really wanted to do a better job, you might want to extend your y-axis max. Let's go to 20. And now we're going to hit graph. And you can kind of see, let's wait for it, and there it is. So where is that? Well, I'd say, and again it says estimate, so I'd say approximately 16 or so. So that's going to go way up here, estimating, and then it's going to come back down through 1, and there we have it. So that's the turning points. So that's it for that problem. Okay, just moving on to number 2, I just had a thought. If I really wanted to find out exactly where that was, remember we can just let x equal 0, and it knocks that out, that out, that out, that out, that out. So there's our y-intercept. I forgot about that little detail. So you could be more than accurate about that. So we could start with this one and just let x equal 0 and know that our y-intercept's 48. So that's why they're saying estimate. That's just going to be way, way, way up here. So I'm just going to put that just for starters. But as you can see, I've typed it in my calculator. I know my y-intercept's going to be 48. It's not going to show it, but let's just take a quick peek. I've changed it back to 10 by 10, positive and negative. And let's see where this thing goes. So that's it right there. So I'm going to start with what I see as my zeros, -2, -4. So -2, -4. And then I can also see 2 and 3. So 2 and 3. We know it goes way up to 48. So I'm just going to draw that in. That's kind of my guesstimate. If I wanted to label that, that'd be 0.48. But it's not asking you to do that. It's saying estimate. So get close. And it's just going to go way down somewhere and then up. I'm sorry, that's horrible, but thank goodness for the word estimate. So now it's going to come through here and then go down to, I don't know, like 6 or so, down a little bit farther, and that's going to come shooting up. And if you want to really get ready for this, I think the reason for these two questions is kind of related to, well, let's give me a second here. So maybe some of you caught this on number 1, but my mind is reeling because I'm looking at x to the 5th. This is an odd function and my leading coefficient's positive, so it's supposed to, the end behavior is supposed to go up to the right, and as you can see I just didn't finish my graph. So it goes down, this guy goes way, way, way down. We could expand our picture if we needed to. But then it comes up through 3, and I just didn't finish that. I don't know if anyone noticed, but it doesn't end here. It ends up here, because the end behavior for an odd function goes up to the right, down to the left, and also there should be 4 bumps. 1, 2, 3, 4. So everything's kind of making sense. That was my point. It's kind of a good question to get started. And now we've got a leading coefficient that's positive. That's an even power, so it should behave just like y equals x squared. In other words, n behavior up to the right, which is true, n behavior up to the left, which is true. So, a lot going on those first two questions, but essentially it's just a graphing calculator and do as good of a job as you can, sort of thing. So, number 3, a polynomial function has the following n behavior. As your roller coaster moves to the left, that's what this is saying, your y value goes up forever. So that means as I go this way, as my roller coaster is trying to move left, that's what this is saying, the function goes up forever. That's what this is saying. So it's kind of like this. And then as your roller coaster moves to the right, your y value, or your range, also, it will go down. And so that's going to be kind of like this. So as my roller coaster moves to the right forever, your y value, which is your range, is going to go down. So it looks like this. So it says describe the degree. Well, first of all, if we go back to this guy, y equals x cubed, we notice it goes up to the right, down to the left. But if we threw a negative in front, it would flip this, so it would resemble, the n behavior would resemble what we're trying to draw. It doesn't tell us how many bumps or anything like that, because it could just be like that. But they're saying, what's the degree? Well, the degree has to be odd. And the leading coefficient needs to be negative because it flips the n behavior of what an odd function's n behavior would look like. So that's a lot of words, but that's basically it. Odd degree, negative leading coefficient. Alright, so guys, if you haven't been using a marker on these types of problems, I think you're kind of making this problem harder than it needs to be. But these numbers are pretty wonky too, so we're going to have to hang in there. But it says fill in the blanks based on the graph to the right. The function is, now we better talk about this, that's your x values, which means from the left to the right. So it's saying from negative infinity, so that means negative infinity is this way, to negative 2. That's my x value. So x is negative 2 right here. So from negative infinity all the way to negative 2, what's happening? Well, right now, two things might be true. It's decreasing, but yet it stops. So I know for sure I could say it's positive because it's above the x-axis. Let's see what this duplicates. And from negative 1, which is right here, to 0.5, which is right here. And as you can see, what's the pattern? Both of those are above the x-axis. So they're trying to get us to see that it's positive. It's considered positive if it's above the x-axis. So my guess is that this is going to be negative, but let's check it out. From the intervals negative 2 to negative 1. So from here to here, that's under the x-axis, and from point half forever, so from here forever, it's also under. So that would be negative. And now it's saying increasing, which means if we're moving left to right, don't forget that, that's very important. Where's it going up? Well, I could pick a couple different ways, but from here to here, we're going to grab that whole thing. So what's my x values in that little interval? That'd be from negative 1.56 all the way to that little x value. It looks like x is 0, but it's not. It's negative 0.107. And then where's it decreasing? Well, I'm going to get out my green marker for this. From here to here, it's decreasing, and from here to here, it's decreasing. So there's two intervals. The first one is from negative infinity all the way to where this ride ends, which is negative 1.56, and it picks back up here at this x, negative 0.107, and then it's decreasing forever, so that'd be forever, infinity. All right, a lot of graphing to get you started. Let's move on to this. Adding and subtracting. Some of you guys need to pay attention to this, because on your quiz you made this crazy box and you multiplied all that by that, and that was a nightmare. But because that's a plus, there's no change. It's like there's a 1 in front and there's a 1 in front there. So really on this problem you just need to add like terms. So negative 8x cubed and 5x cubed is negative 3x cubed. That's my pink. So this colors kind of help. And then I go down the line. 7x squared plus 3x squared is 10x squared. And then new color, x and negative 2x gives us negative 1x, and that's my orange stuff. And then last but not least, negative 9 minus 1 is negative 10. So this would be my answer, because I can't add any of those because they're not like terms. Now this problem is very similar, but the first thing I better do is distribute this negative, because that's a game changer, to everything. So it's negative 2y to the 4th. Negative times a negative is positive. Negative times a positive is negative. And again, two negatives make a positive. So now, without colors, remember there's a 1 in front of here, so no change, no change, no change, no change, no change. 9y to the 4th minus 2y to the 4th is 7y to the 4th. Those are gone. Negative 1y cubed plus 3y cubed is 2y cubed. Those are gone. 4y squared, and there ain't none, so don't forget it. Part of this is just being organized. Y minus 6y is negative 5y. Negative 2 plus 7 would be 5. As long as I didn't make a silly mistake, that should be it. Okay, number 7. I'm going to start by multiplying these two binomials and then multiply my result by that. So I've got my box set up. 9x squared minus x, 45x minus 5. I'm looking for like terms. So it'd be 9x squared. That's a little bit of a yucky situation. That's a big number. 44x minus 5. Now I got to multiply that by 7x plus 2. And what I recommended you guys do, you don't have to, but this is a very organized way of doing things, is put your stuff in a box again, and here we go. 63x cubed, get out my calculator, that's 280, I just don't want to screw up. So 7 times 44, 308. So 308x squared minus 35x, 18x squared, 88x minus 10. So 63x cubed, and then this plus this would be 326x squared. 88 minus 35 is 53 minus 10. And that is a little difficult because the numbers got pumped up a little bit on that one. All right, number 8, it's going to bother you guys a little bit maybe, but a rectangular box has the following dimensions. Length, I'm going to draw this all out a second. All right, so there's the visual image, but don't forget, it says write and simplify, that's the key. An expression to represent the volume. Well, volume of a rectangular box, you guys have taken geometry, length times width times height. We're just going to have to throw some stuff in there. So that's 15 minus x. That's the length, times the width, 10 minus 2x, times the height, which is 2x. All right. My fear is that you guys are going to take this and distribute it to everything. If you don't know exactly what to do, chunk it out. You can't go wrong. In other words, if it was 2 times 3 times 4, you guys would go 6 times 4, which is 24. In this case, you would not distribute the 2 to both things. That would mess your answer up. So all I'm saying is chunk it out. And so I'm going to FOIL this. 15 times 10 is 150. I'm going to do a little math in my head. Negative 30x minus 10x is negative 40x, and then negative times a negative is positive, and then that'd be 2x squared. Now that I've FOILed that out, I'm now going to multiply that by 2x. So distribute, distribute, distribute. Typically you write your highest powered thing first, so I'm going to do things a little backwards here. That'd be 4x cubed, and then minus 80x, and then plus 300x. If you want to get really fancy, that's the volume based on x. So that's the whole thing. So it says write and simplify the expression. Well, this is a correct start, but they wanted you to actually multiply it all out. That's what the whole simplify part of it means. Okay? All right. Next one. So a student says the graph of blah, blah, blah is a vertical stretch and a translation up 1 unit of the parent function. Explain the student's error. First of all, that's my letter A. If A is less than 1, it's not a stretch. That would be a shrink. And up 1 unit is good because that's my D, and so my mistake was, or the student's mistake was right there. How does the graph of blah, blah, blah compare to the graph of the parent function? Well, if this is cubed, then the parent function is y equals x cubed. All you need to do for this one is follow your rules. That's a vertical stretch, factor of 2, left 1, down 3. Those should be like yawners by now. Okay, number 11. The volume of a refrigerator in cubic centimeters is given by the function blah, blah, blah. So a refrigerator is a lot like that. It's a rectangular solid, and so you got kind of length times width times height thing going on. Write a new function for the volume of the refrigerator in standard form. What that means is simply multiply it all out. Well, remember what I said. If you have 2 times 3 times 4, see, my fear is you're going to multiply everything by x. But that's not accurate. You multiply the first 2 things and then multiply your result by the last thing. So let's just distribute that x. That'd be x squared plus x times x minus 2. Now we have a FOIL situation. This times this is x cubed. This would be 2x squared. This would be x squared. And this would be minus 2x. We got some like terms here. So x cubed, if you want to get fancy, volume, depending on x, is equal to x cubed plus 3x squared minus 2x. That's it for that one. Okay, so that's a 17, nearly 18-minute video. I think I'm going to stop this one, and then part 2 will start 3, 4. All right. See you in a second.